Okay, day 4, we're going to do some more work with derivatives, specifically the first derivative. So we look at our definition that we've been working on for the last couple of days. And you have to realize that in math we do use synonyms, and whenever I say the word derivative, I mean any of these listed before. Slope of the tangent line, slope of the curve, y prime, f prime. Because there's only one prime on the f, that is known as the first derivative. This is going to be key. We're going to look at some graphs today. So let's look at some comparisons. So if we look at these problems here, they want to know the average rate of change between x equals 1 and x equals 3, or the average rate of change between x equals 3 and x equals 5. Well, x equals 1 is right here. 3 is right here. The average change would be the slope, whatever it may be, and 3 to 5 would be this slope here. And obviously, the first one in red, and I'll make them different colors. Make the other one pink. The one in red is definitely steeper than the one in pink, so the average rate of change for this one is greater than another one. Now when we want to do F2 versus F5, well, I'm going to erase all this. These are just y values. Not everything we do is derivative, so here's f of 2, here's f of 5, and f5 definitely has a higher y value. Now we want to do f prime of 1, f prime of 4. So I'm going to erase this. This is the slope of the curve at that point, or what I call the tangent line. So here's 1, and here would be its tangent line, best I can do. And here's 4, and here's its tangent line. And the black one is definitely steeper than the orange one. And then finally, we want to compare all these values. So we have to be very careful on what you're comparing. First, let's draw. If I do this right through the middle here, right, this diagonal line, this is the slope y equals x, or a slope that is equal to 1. Ooh, that's terrible. Okay. So I want to compare the numbers 0, 1, f prime of 2, f prime of 3, and this value, which is really, if you look at it, it's 3 minus 2, which is just equal to 1. So this is the average rate of change between points x equals 3 and x equals 2. Well, let's take a color, red. So f prime of 2, I go to 2, I draw f prime, and this slope, it's a little bit bigger than 1. And at 3, which is right here, oh, this is right here. I'll do this in pink. This one is definitely less than 1. I'll do this one in bright orange. It's the slope between these 2 points. And it's actually, if you look very closely, a little bit less than 1. So if I had to put these in order from low to high, the lowest one is definitely 0. And then f prime of 3 is less than 1. And then f of 3 minus f of 2 is a little bit less than 1. then I have the number 1, and then I have f prime of 2. And those are the going from low to high. It's hard to tell sometimes with graphs if they're very close to 1, but it's really just an approximation. Another way to approximate the derivative at a specific x value is really just take the slope between the point right before it. So, or the one after it. I could just take these two values and approximate that the change in y here is 5 and the change in x is 1. So this is 5. This is also 5. This is 4. This is 2, 0. It's down 3, down 8, down 14. And since there's no point next to it, I could just leave it blank. And for this one, I'm going to do the same thing, except now you got to be careful because this is the change in y is negative 0.2, and the change in x is 0.5, so that's negative 0.4. This is negative 0.6, 0, 0.2, 0.6, 0.6, 0, and then negative 1.2, and since there's not another point here, I won't be able to do all that. So next we're going to look at how we figure out how to draw graphs for functions and their derivatives. So I give you the formulas. It wasn't really important what the formulas were for each of these f of x, but I want to draw f prime for each of these graphs. And the idea is that f prime is just the slope. Let me grab this. The slope of the curve. Okay, so this first one is pretty easy. It doesn't matter where you go. If you go between these 2 points, the slope is 2, or these 2 points, the slope is still 2, or any 2 points anywhere, the slope is always 2. So when I draw this derivative, I'm just going to draw this because the idea is the slope of f of x becomes the y values of f prime of x. So this problem right here, this y value was always 2 because the slope of the original function is always 2. Now it's going to be a little bit different when you have something that's curved. A line is a line. So if I look carefully at this, I'm going to pay attention to mins and maxes. So right here, I have a max. And the one thing I know about a max is it has a slope equal to 0. So a slope of 0 is going to turn into an x-intercept over here. So right here I have an x-intercept at the same x value. So this was at x equals 1, this is still at x equals 1. But if I look at this part of the graph, I realize that this is uphill, so my slope is always equal to a positive. Over here, after the vertex, I have a slope that is always equal to a negative. So I have to draw a graph that has positive values, 0, negative values, because again, the slope goes this way. It doesn't really matter. We'll figure it out later, more details, but right now, I just have to have something that goes positive, 0, negative as the best I can, because the idea is that over here, y is equal to positive, right here, y is equal to 0, and at the tail end, y is equal to a negative because of the same idea. The slope of this graph becomes the y values on this graph. Now I have another graph here, and it's actually a little bit better because I have a couple mins and maxes. So right here, I have a max, and right here I have another max. And what I do now is that at these maxes, right here, the slope is equal to 0, and that's really at about x equals a half. So I'm going to put a little dot here, x-intercept of x equals a half. I'm going to put one right here. It looks like 1, 2, 3. X equals 3. I'm going to put another x-intercept right here at x equals 3. If I pay attention, this slope here on the first part is uphill. This part is going downhill, and this last part is going uphill. So to me, I need something that has positive y's, 0, negative y's, 0, positive y's. So it looks something like this. And it's okay, it's not perfect. But if you look carefully, these are positive y's. Right here is y equals 0. These are negative y's. Back to y equals 0. And then we have at the very end positive y's because something really stands out. The slope on this graph becomes the y values on this graph. And that's the way it works. So this is how we're going to be able to look at graphs and figure out what the derivative graph should look like. So basically, in summary, we have this. F prime, also known as the first derivative, that f prime is positive, has positive y values when the function is increasing or going uphill. F prime is negative, or its y values is negative, when the function is decreasing or going downhill. And then f prime is equal to 0 when the function is horizontal, or what we even better have mins and maxes. Okay, thank you for watching this video.